Hello guys and welcome back. In this video we're going to try to start doing the tracing part of our logic here. Okay, to start with, we're going to try to do a tracing through one function called sphere trace the trace, right, from a start to the end. The idea here is that we find the location of these IK joint, this one and this one, right? And then we want to use this their x and y location, but for the z location, we want to use where this root is. Okay, so we're not going to trace from these two. We're going to trace starting from this bottom, right? So bring this position down to the ground. That's where we start. And then we're going to go above it for like 30 units. Because what if there's a platform here? I'm going to trace from somewhere higher from the ground, right? And then we trace down maybe 50 below the ground to find there's any surface underneath, right? That's our tracing range. So to be more precise, then our tracing start will be this blue one here. That's 30 units above the ground. And then we're going to trace towards the purple one on the bottom, 50 units below the ground, right? That's our tracing range. We're going to do a sphere trace this direction. Okay, if we hit any surface, then we offset the IK joint there and use that position to drive the IK of the leg. Okay, that's the idea here. Okay, so the function we're going to use is trace, sphere trace by trace channel. And we can just define that start and end. Again, the start is here and the end is here, right? And then we can easily calculate that by referencing the positioning of those joints. Okay, so go to the hierarchy here and let's look for the IK foot left. Just drag it over here and get bone. That's going to get the position of the bone or the transform. Okay, and then that is indeed the position of this point, right? The left leg ankle position, right? That's what it is. Okay, or rather this one. But then, yeah, that's the one. And then we're going to try to offset it to the ground. So we do have the translation. I'm just gonna use this x and y, but use the z position of basically the root. So let me drag the root over as well, and then get bone. Okay, so that's the root, and then we're gonna compose together compose together a vector. So make a vector. This one. I'm going to use the x and y from the ankle IK, right, IK foot, and then I'm going to use the z of the root joint, right? So this position is basically in my diagram, these positions, those yellow ones, right? They're actually the one on the ground, but they're having the same x and y of their respective ankle, right? So we're going to go there and then we're going to go up 30 units. So I'm going to do a add and then by 30, right? And that will be our trace start. Okay, and the trace end will be subtract, right, by 50 to go below the ground on the Z. Those are very good values, and drag that over here to the end. So we're going to trace from there to there, right? Basically now we have this trace from the blue dot to the purple dot, from top to the bottom, a sphere trace. The radius of the sphere tracing can be smaller, like 3, and we're going to trace over visibility. We're okay with that. Okay, another thing we can do is to change the y of the addition to 5. Okay, why are we doing that? Well, we're offsetting on the y by a positive value. So basically we're offsetting this direction, which is the front of the character, right? We're doing that because the location of these ankle or a foot IK is here, but we'd rather trace from what's in front of them, the tip or the ball of the foot, right? So we're adding a little bit of offset. So we're tracing not exactly where the ankle is, but the ball of the foot is, right? That's more accurate. Okay. So that's why we're adding that 5, but without it's not going to be that much of a difference, but adding 5 will be making the result more accurate. Okay, and then this hit location, is actually not the world location. If you have the cursor here, and first of all, you see this function is not the same function you have seen in normal blueprint in Unreal Engine. This is not those functions. This is a specific one designed for the control rig. It doesn't really give you the world location of the trace, right? The hit location is in relation to the local rig space. By that, what I mean is it's in relation to the root joint, more or less, right? It's in relation to the root. Okay, so this is not going to be the world 3D world position here in the scene, right? And that's an important distinction you need to understand. This is not the world space, even though it says that the global space is also not the world space. It's a rig space. Okay. All right, with that being explained, this hit locations Z is basically how much we need to offset our foot, right, to have the IK to be the foot to be planted on the ground and for the IK to follow that way. Okay, now notice that we're getting the left and we need to do the same thing for the right foot. So it'd be better if we make a function that can do this for us, so we can do this on both the left and right. Let's go to the Map Blueprint tab, and then we're gonna make a function. Okay, I'm gonna call this guy foot trace. Okay, this is only does the foot trace, doesn't do the hand. So I'm gonna go back here to the outside and just copy all these, or just Control X to cut all these and go double click into the foot trace and Control V to paste them in. Okay, and all we have to do is just insert this code in between. One thing I want to define is which leg are we talking about, which foot are we talking about. That can be determined by this atom. Just drag that over to the in tray, and that will make the input. I'm going to change that atom from foot IK. Okay, foot IK. Okay, and then the root is usually the root, but if you want to define that, you can drag that atom to there also, and you can say then that the other one is the root. Okay, that's going to be the input, and the output I'm worrying about or trying to get is basically that hit location. Just drag that over here. Okay, I'm going to call this guy offset. Okay, and then I'm going to compile and save it. Okay, now with this function set up, we can now go back here to the forward solve, and then we can just drag in the foot trace and just call it there. Okay, and we got that offset. And then in this case, we got the left foot. Okay, and for the Z, I'm gonna drag out and then promote to a variable. Okay, I'm gonna call this guy, this new variable here underneath. I'm gonna call this guy foot left target offset, or offset target. I think it makes a bit more sense. That's where we want the foot to be offset into, right? That much of offset on the Z. So I guess to be more precise, Z offset target. Okay, and then that's the left, and then we just need to copy that and paste it in there and connect that in there. But this time we change the name from IK foot left to IK foot foot right. Oh, doesn't do that. IK foot right. This guy, yeah. And root is still the same root, so we shouldn't be need to change that. But this one will be not the left. Let's just promote to another variable, right? And this one will be foot right Z offset. Okay, compile and save that. Okay, alrighty. And then with those two, let's just examine what we're getting. We're gonna do a print. Okay, and let's just get the values. Get foot left, and drag that out into the value, right? And that's 1. And then I want to do another print, or maybe just this one. I don't know. Let's just have both. Yeah. So this one here, and then drag the R, and put the R offset in the value. Okay. So we'll try to see if we're getting those two correctly. Okay, and I guess we can do that because we have already inserted that in. can see that's already printing something, right? But let's try to play the game and see if we're able to see that. So I'm gonna play the game. You can see we're getting that negative 0.3, right? But let's go to the slope. You can see the values are changing, right? You can see one of those is negative 5, and that is probably the foot on the back. It needs to go down that much, right? And you can see the other one is nearing 0 is because it's right on the surface, so it doesn't need to offset, right? So you can see how those values are pretty nice. If you go here and we just have the front foot there, you can see we're seeing negative 21 there, and that makes sense because it's kind of like all the way above the air. It needs to go down that much, right, to be planted on the surface underneath. So we're getting those data correctly, and then we can just move on and trying to really shift them. Okay, so I want to go ahead and do that in the next video. Okay, see you guys next time.